This is a screencast to calculate the velocity of a ball that is thrown upward or downward. A ball is thrown downward at 7.5 meters per second. Find its velocity 1.5 seconds after it is thrown. We see in the problem that the initial velocity of the ball is 7.5 meters per second, and the direction is down. The acceleration is the acceleration of gravity, and that's always down. We're going to take an estimate of value 10 meters per second squared for the acceleration of gravity. And again, that direction is down. Since both of our values are in the direction down, let's take down to be positive. That will allow our V0, initial velocity, to be 7.5 meters per second, and our acceleration to also be a positive, this time 10 meters per second squared. The equation that relates initial velocity, final velocity, acceleration, and time is V equals V0 plus AT. Now we can plug in our values. Our initial velocity was 7.5 meters per second. Our acceleration was 10 meters per second squared, and the time was 1.5 seconds. To calculate that, use your order of operation agreement, multiply before you add, and when you do that, you should get 22.5 meters per second. The positive indicates that that velocity is down. Now let's look at an example. Now let's look at an example where the ball was thrown upward. The ball is thrown upward at 12 meters per second. Find its velocity 0.9 seconds after it is thrown. The initial velocity is 12 meters per second. Up. The acceleration is still the acceleration of gravity, and so it's still down 10 meters per second squared. This time, one of our values is up and one is down, so we have to make a decision about positive. Let's take positive to be up. That allows our V0 to be a positive 12 meters per second, and our acceleration to be a negative 10 meters per second squared. Again, to relate the final velocity, initial velocity, acceleration, and time, we have v equals v naught plus at. Plugging in the numbers, we get 12 meters per second plus a negative, I'll write that as a minus, 10 meters per second squared times the time, 0.9 seconds. Following the order of operations agreement, where you multiply before you subtract, we'll get 3 meters per second. That came out positive, and positive means up in this particular problem. What if you had the same problem, but this time you want the velocity 2.5 seconds after it's thrown? Using the same sign convention of positive up, our initial velocity is still 12 meters per second, and our acceleration is still negative 10 meters per second squared. And then v equals v naught plus at as before. Plugging in the numbers, you get 12 meters per second minus 10 meters per second squared times 2.5 seconds. When you do the calculation, you get negative 13 meters per second. The negative indicates down.